on problem number 27, solve the system of equations. We have x, y, and z, and we have three equations. Remember, if you have three variables, you do need three equations, and we do have them. I want to be able to cancel the x's, the y's, or the z's. It doesn't matter, but you want to be able to select the one that has easier numbers to cancel, or the one that has variables by themselves. Makes it just a bit easier. So in this case, if you notice the x's, there are two x's by themselves, so the x's might be easier to cancel. I'm going to cancel the x's twice. First, I can get the first or second equation, or the first one and the last one, or the second one and the last one. In this case, it might be easier to get the first and second, and to cancel the x's, I'm going to multiply this by -1. So it gives me a negative x minus 3y minus 2z is equal to -2. The second equation will stay exactly as it is. The x's cancel, and now I just have 2y plus z is equal to 1. I want to cancel the x's once again, so I can have a choice. I can get the first one and the last one, or the second one and the last one. In this case, it doesn't matter, but I'm going to select the first one and the last one. And I'm going to cancel the x's again. So therefore, I'm going to have to multiply this equation by -5. So it cancels with a 5x. -5 times x is -5x minus 15y minus 10z is equal to -10. The last equation will stay exactly as it is. Now the x's cancel once again. Remember, if you cancel the x's the first time, you need to cancel the x's the second time. I'm going to add them, so it gives me -13y minus 7z is equal to -3. Now, I want to combine both equations, and I want to cancel the y's or the z's. But let me go ahead and bring them back over here. Which one do you guys want to cancel? In this case, probably the z's will be easier, so I'll multiply this one by 7. 7 times 2y is 14y. 7 times z is positive 14z, or 7z. Careful, one little mistake, and then you end up with a fraction or the incorrect answer. So we have 7z, so you have to be extra careful. Equal to 7. The second equation will stay exactly as it is, because that way the z's will cancel. The z's cancel, and we have 14y minus 13y is just y is equal to 4. Now I can take this y value and plug into either one of those equations, so that way we can get the z value. I usually select the one that has smaller numbers, so I must select this equation here. So I'm going to find z. We have 2y plus z is equal to 1. But instead of the y, I'm going to replace it with a 4. That gives me 8 plus z is equal to 1. I'm going to move my 8 to the right, becomes a -8. So therefore I have z is equal to -7. And now that I have two solutions, I can go and plug it back into the original inequality, so original equation. I must select, it doesn't matter which one you plug it in, I must select the second one. So therefore, the only one that I'm missing is x. So I'm going to find x. I have x plus 3, y plus 2z is equal to 2. So instead of the y, I'm going to plug in a 4. Instead of the z, I'm going to plug in a -7. I have x plus 12 minus 14 equal to 2. I'm going to combine like terms. So it gives me a -2 is equal to 2. Move the 2 to the right, becomes a positive 2. So therefore x is equal to 4. So therefore my solution, my x value is 4, my y value is 4, and my z is -7. Now to double check my answer, I just need to plug it back into each one of those equations, and it should give me a true statement.